Lesson 1-3, Section F. First objective is to be able to name three-dimensional figures correctly. When we name three-dimensional solids, we have to take three things into account. What type of figure is it? So it could be a prism, which has got two parallel bases, and the sides of a prism will always be rectangles. Maybe it's a pyramid. Whoop, let's try spelling that correctly. Pyramid, which only has one base, and the sides would be triangles. It could also be a cylinder or a cone. These are different types of three-dimensional solids. The next thing you have to figure out, especially when it's a prism or pyramid, is what is the shape of the base. As we move on, that's going to become very important. After that, you need to consider, is it right, meaning standing straight up and down, or is it oblique, leaning to the side? All right, so let's check the next one. Okay, so there are 6 general types of solids we're going to look at. Prisms, cylinders, pyramids, cones, spheres, and hemispheres. Hemisphere is really just half of a sphere. A solid made of polygons, remember what that means, no curves, gaps, or overlaps, is called a polyhedron. The plural of that is polyhedra. So for example, this has got 1, 2, 3, 4, 5, 6 sides. So it's a hexagonal, comes to a point, triangular sides, therefore it's a pyramid. So this is a hexagonal pyramid. This is not a polyhedron because it's got curved surfaces, but you should still be able to name this as a cone. Every polyhedron is composed of faces, edges, and vertices. So on the figure to the left, which is a triangular prism, I know that because I've got 2 triangular bases and my sides are rectangles. So when I look at this triangle on the end is a base. Okay? In general, it's a face. It will be our base. But in terms of faces, edges, and vertices, this is the face of the figure. Over here, you're looking at this rectangle. That would be the face of our rectangular prism. Okay? The next one is this line right here. This line, or this line right here, these are edges. And the last thing is this little corner right here, and this would be called a vertex. Plural of vertex would be vertices. In a polyhedron, each face is a polygon. So our edge is where 2 faces intersect. It's kind of, if you were making these, it would be where the folds are. Your vertices join together 3 or more edges. So frequently we'll call these corners, but in geometry we try to be very specific with our language, so we'll refer to those as vertices. So when we're finding the surface area and volume, we have to know the height of the figure. And this is a very, very important piece of information. The height is always perpendicular to the base, which means that they meet at right angles. Furthermore, the base of the solid may not be on the bottom. Often we turn the figure so we can see it at different angles. It makes it easier to see. So when we look at this, on the bottom we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagon. I have 2 of those, but this is my base. So this is an octagonal prism. Here, my bases are the triangles. This is one that we would call oblique, because you see how your height has to be outside the figure for it to be perpendicular to your base. Here, my base is what it's sitting on this time, which is, without markings, I can't call that a square. So I'm going to call this rectangular. And since my sides are triangles and it comes to a point, this is a pyramid. It's very important not to call it a square pyramid unless you see markings that make you know that that's a square. The last one over here, again, my base and height are perpendicular. This is a cone. Doesn't matter that it's not sitting on a base. The base is the circle. My right rectangular prism, if you look at the bottom, this explains what how your name is devised. It's right because your lateral edges are at right angles to the bases. Informally, we say that it's standing straight up. That's what you're used to. It's rectangular because the bases are rectangles, and it's a prism because your bases are congruent and parallel. You have two of them, and the lateral faces are rectangles. So we look at this. This top part right here will be our base. Okay? So will this one right here. This is also a base. Your bases are faces. But in this case, so are the ones that they're showing here on the side. So this is also a face. If you want to be specific, you can call it a lateral face if you need to do so. On the bottom here, this is pointing to these lines, so we know that these are edges. Okay? These two are also edges. Since our height has to be perpendicular to our base, this is going to be the height of the figure. Here's an oblique cylinder. It looks like a normal cylinder that's kind of been squished sideways. Our base is still right here. It's still the circles. So this is a base. This is labeled to be the radius of our circle. Okay? The slanted side here is a slant height. This is also called a lateral height, which is where the L comes from. It's very important that you can understand the difference between the true height, which has to be perpendicular to the base, so that would be a segment outside, and the slant height, which is going to be part of the cylinder itself. It's oblique because our bases are parallel, but not directly above each other, so it's kind of at an angle. Your slant height is different than your true height, and the height being the one that's perpendicular to the base. Next, we have a right rectangular square pyramid. Okay, and again, looking at these, if I'm pointing to this is like a fold, so this is going to be an edge. Okay, this, because it's perpendicular to the base, is my true height. There's my height. My slant height is going to be this one over here. This is my slant height. Okay? And when I'm looking at this one pointing to this side right here, this is going to be a face, or a lateral face if you prefer. Again, we call this regular because the base is a regular polygon, and you would be given that information, and because the vertex is directly over the center of the base. If this is regular, then that rectangle would have to be a square, and we would let you know. Square because that's what a regular rectangle is. And it's a pyramid because the base is a polygon, the lateral faces are triangles, and they have a common vertex. Notice that your slant height, again, is different than your true height. Your true height, always perpendicular to the base. Obviously an important fact because we keep repeating it. Last one here is a right cone. So we've got the true height of the cone, and I know that that's my height because they're perpendicular. My slant height is going off the side. Okay, so here is my slant height right here. Okay, point at the top. This is my vertex. Here's the radius of the circle. This is the base of my figure, the circle is. And what this last one is pointing to is the curved surface that creates the side. And this is going to be your lateral surface. Again, it's right because my vertex is directly over the center of the base. It's a cone whose is a solid whose base is a circle. The lateral surface connects to the base. Now you have a trimeme. So you should write out the difference between height and slant height. Again, very important concept in geometry. When we check your notes, if your trimeme is not done, you will not get credit for the notes. After you've done this, you should go retake quiz F again and aim for that perfect score. That's the end of video 1-3, section F.